So Michael, thank you for joining us, and over to you. Tell us everything that you want to share with us today.
I have a short talk, and this talk is really trying to just introduce who we are and what we do. I'm not going to go into the full gory story right now of all of our technical contributions in the field of quantum computing, or even a description of what quantum computing is. If you're interested in those kinds of topics, then please do feel free to ask me during the Q&A session. But the starting point is, what is QControl and who are we? What do we do? QControl is a company that I founded in 2017. Based on the research career that I've had. I'm also a professor of quantum physics and quantum technology at the University of Sydney. I've worked in the United States. I was educated in the United States and moved here in 2010. Founded QControl in 2017. Based on a lot of the effort that we had made in trying to understand how to make a new class of quantum technologies that take advantage of the science of very small things in order to do fundamentally new things. And we're really excited about this particular topic area because this emerging new discipline of quantum technology promises to be as transformational in the 21st century as harnessing electricity was in the 19th. And I don't mean this just because it's the newest and shiniest thing. I mean it because there are deep parallels in the way we first learned to access and then exploit the flow of electricity to develop new technologies, and how today we've been learning to access and now exploit new physical phenomena in the form of quantum physical phenomena. Our role in this emerging community is to help our customers and our partners take control of their quantum future. And we do this by providing infrastructure software focused on a discipline called quantum control engineering. Now, if you're not that familiar, control engineering is the discipline that makes everything work. I'll come back to this in a few minutes, but the idea for us is to be a critical enabler for the emerging quantum technology sector by sharing our knowledge and our expertise as professionally engineered software for different applications of quantum technology, from the ones that you hear a lot about, like quantum computing, to the ones that maybe you don't hear about as much, like new kinds of advanced navigational technologies that leverage quantum physics for improved positioning accuracy, new things that replace GPS in areas where we don't have access to GPS. Now, since our founding, we've become quite active all around the world. We have both commercial engagements in terms of product sales and also R&D engagements with some of the biggest companies in the world and research institutes in this space. They range from IBM, who's been a partner of ours since early 2018, and Rigetti Computing, which is a company that builds quantum computers in Silicon Valley. We are a supplier to them. But also, as you see, companies like Fermilab, or organizations like Fermilab, one of the national labs in the United States, NIST, National Institute of Standards and Technology in the US, a number of universities, public sector research organizations, and the like. And we've been fortunate, based on the efforts we've undertaken, to be featured in a wide variety of really exciting outlets, most recently The Economist. Now, we all are wise enough to take those with a grain of salt, but of course, it's nice recognition for the team when their work gets written up in The Economist, say. Now, to Sally-Ann's point, we are a company that's growing rapidly. In fact, in 2020, which of course all of you know has been a year of global contraction in the economy based on COVID, we have almost doubled in size, right? We went from 23 up to 43 people on the team. We're continuing to grow. And this is a really great example of how deep tech organizations have the added benefit of building resilience in the economy, that we're not all susceptible to the same kinds of common economic shocks that would hit, say, the retail sector or property or hospitality or the like. Now, the other main point that I want to make here is that our team is not just a set of clones of me. Even though we are a heavily R&D focused organization, with a huge effort in building completely new algorithmic techniques to control and manipulate, say, quantum computers or quantum sensors, we have only about half of our team focused on that. We do, in fact, at this point, have the world's largest collection of professional quantum control engineers, people at the PhD level who are experts in this field. But in addition, we have a team almost of equal size that is focused on product engineering and the business aspects of bringing our technologies to the market. You know, as I mentioned earlier, we share our expertise as professionally engineered software. So we have software engineers on the team who come from backgrounds in, say, back-end engineering or DevOps or front-end engineering. And in fact, my first hire was a non-quantum chief technology officer. My second hire was a completely non-quantum designer. So a product designer and a general graphic designer who joined us right from the beginning. So there are many different opportunities for people coming from completely distinct backgrounds, very far away from, or at least nominally very far away from quantum physics and engineering, who play a critical role in our success and, of course, the broader industry. In this field, our role is to help our users break free from the constraints they face on quantum computers. Now, one thing that we don't necessarily talk about so much, because we like to air the good news and not the bad news, is that when we think about quantum computing hardware that exists today, those machines are extremely unstable. That over very short periods of time, they break. And our job at QControl is to help stabilize them. And we do this by control engineering. So we provide software solutions that make quantum computers perform better. And the story is actually quite similar in other areas of quantum technology as well, like the navigational technologies I mentioned, or new kinds of sensors for gravitational fields that can be used to detect water underground and the like. And I want to come back and conclude with this message about control engineering, because we've seen that through the development of technology all across history, that control has been a critical enabler. My favorite example of this goes back to the Wright brothers. And the Wright brothers famously were the first to fly. They actually were not the first to fly. They were the first to achieve manned powered controlled flight. And that distinction, while subtle, is actually quite important, because they entered an industry where there were many, many players building flying machines. But they achieved what others couldn't because they brought a control theoretic perspective. They added ideas like deformable airfoils, that you could change the shape of the wing at the will of the pilot. And it's nicely summed up in this quote here from a book about them. From the beginning, their goal was to devise a control system that would give them absolute command over the motion of a machine in every axis all the time. Control superseded stability. That bringing control to the technology was the most important thing that they could do. We see the same things playing out today in drone technology, in walking robots and the like. And we're excited to become the organization that helps bring quantum technology to reality. So with that, I want to hand back to Sally Ann and point you to our website if you'd like to learn more about what we do, our career openings and the like, but then get into some of the discussion here. So thanks a lot.
Brilliant. That was fantastic, Michael. I think I actually heard you explain things in a slightly different way to what I've heard in the past. And I think every time you do, as a non-quantum physicist, and actually a non-physicist in general, that is not my background, I always get something new. And I always get a greater understanding of the depth of the significance of what it is that you're trying to do, because it's actually not just a narrow, as I understand it, it's not just a narrow thing that you're trying to do. It's actually an enabling technology that is going to be able to be used, really by everybody. And it's almost like without you, the quantum future, without QControl, the quantum future may not be realized for people in the way that or realized in the way that we see that potential. So at least that was kind of my takeaway today is it's critical, absolutely critical.
Then I've done my job.
Yeah, excellent, great, awesome. I'm glad I got that. But I think it's really exciting, right? Like to think about that is breakthrough and groundbreaking that an Australian company is actually doing this, right? And that it is the potential impact is there for the entire planet to be able to access quantum in new ways to do things. I want to dig into a little bit more of this. My first question was about how do you sell QControl to a non-quantum physicist? Well, you've already sold me on that. But what I'd love to unpack a little bit more if you can, you mentioned on your slides all the people that you're working with and the sorts of companies. Are you able to tell us any of the kinds of solutions that people are bringing to market in broad thematic areas by being able to access, quantum technologies through what you provide? Like, what is it that they're doing? Are they using it in health? Is it agriculture? Is it navigation? What kind of stuff are you seeing, and what ones get you the most excited about?
It's a great question. Let me give you two concrete examples. One is related to quantum computing. And quantum computing is just a new way of processing information. And it allows us to tackle some problems that are just really hard for regular computers, even crazy big supercomputers. IBM is a partner of ours. We're part of the IBM Startup Network, and we have the IBM Q Startup Network around quantum technology. And we provide them solutions that make their quantum computing hardware perform better.
Mm-hmm.
How does that end up having an end user impact? Well, those quantum computers are now being applied for problems in, say, pharmaceutical discovery, where people are running the calculations that help us understand chemistry on quantum computers. Now, today, we're still running very small toy problems. We're not running, real drug discovery like you might for, say, COVID or something like that. But we're just getting our feet wet in applying quantum computers to these problems. Again, the hardware is really unstable. It tends to break a lot. Our solutions improve the performance. And as one, very concrete example of that performance improvement, we've shown that with the kinds of definitions of the gate operations, that is the quantum logic that composes an algorithm, using QControl solutions, excuse me, we can improve the system uptime to a level that just that one benefit, forget about any other benefits of our software, adds something like $500,000 of billable time per year for one machine.
Wow.
Right. So you can have really big impacts on the economic aspects of this computing service. It's cloud-based quantum as a service, as a model. And then, the other example I wanted to give was with our partner, Advanced Navigation. Advanced Navigation is a customer of ours. They've become more than that. They've become an R&D partner. Advanced Navigation makes what are called inertial navigation systems. These are systems that are, they've been in airplanes and boats forever. They help you determine where you're going by measuring changes in, your direction. So you feel an acceleration one way or the other. And if you keep recording that information, you can figure out where you are, as long as you knew where you started. So this is really important if you're talking about circumstances where GPS is denied. And that could be obviously in space where there is no GPS, or it could be in an adversarial context. So maybe you're on the battlefield and your enemy jams your GPS, right? You still need to be able to position. Well, we are designing and now deploying new kinds of quantum-enabled inertial navigation systems with advanced navigation that give you orders of magnitude improvement in how long you can operate without GPS signals. And, this is research as well as product development focus. It combines contributions from many different members of our team, but it's a way that we can deliver real value for defense, for aerospace, for the space sector, even for transport, right? Autonomous vehicle networks need high quality positioning. If they go through tunnels for a while, you don't want them to drift into the wall because they don't have a good GPS signal, right? So that's another direct way where our activities are impacting in the real world.
I find that so fascinating to hear you talk about this, because I think this is what we need to have in the quantum conversation is like, what does that look like in a tangible output a little bit for people? You mentioned just then on the navigational side that your team was heavily involved in doing that. So it sounds like your team is not only just dealing with, with sort of this, if I can call it a middle layer between machine and customer and improvements, but there's also another layer of sort of research and capabilities that you also offer as a service. Is that kind of correct to say that?
Absolutely. So QControl started, like any company started, with a very narrow focus on an area where we knew we had a major strategic advantage, where we knew we had a technological advantage, and we've gradually diversified. But from day one, our objective was to be the trusted provider of quantum control solutions across all verticals and all applications in quantum, right? So that started with quantum computing. It started with this infrastructure software, we call it quantum firmware, to make quantum computers perform better. But it by design has gradually expanded. It now includes a very broad activity in quantum sensing, now navigation, and through our partnerships, we're doing not only software engineering, we're also doing hardware engineering, delivering these new capabilities. So, I think it's an important lesson that any deep tech company needs to start in what they're really known to be good at. And then you can continue to expand by building the right team and attracting the right personnel and capital, of course.
I think that's such a great lesson. And I think you've illustrated it really beautifully. And it kind of ties into one of the questions that have come through that I'm going to take and tweak a little bit from Wyatt about, he's said that the quantum computing space has several different verticals, small startups, big industry players, academia, et cetera. Each space has different needs and different goals and motivations. How's this complexity shaped your market strategy? Well, I think you've sort of touched on that, but I guess the add-on question to that I'd love to ask is, what do you think is next? You've started out in your expertise, you've added some layers. Where are you hoping to go from, or can you tell us, or is that too commercial?
I can tell you some things that are going on. It's a great question because the needs of potential users are so diverse. And excuse me, it's very clear that when we started, we had this reasonably narrow focus on delivering value in this quantum firmware layer. The quantum firmware layer and the tools that we built to deploy it are useful for R&D professionals, right? People who build quantum computers for a living, people who do research on how to build quantum computers for a living. The reality is that there are a lot more people who are not that than there are that. And so, from again, day one, we had a product strategy in mind that was going to be diversified, but you have to start somewhere, right? Yeah. So we started with these core tools. The first tool the core tool that we have in the market now is called Boulder Opal. It's the background that you see here. This is the R&D professional targeting tool. But then we have one product that's in the market that's being re-released in 2021. It was always a bit of a test balloon, and we've learned a lot from it. This is called Black Opal, and it is for students and newcomers to the field, people who are interested in getting into quantum technology, but don't really have a physics background and want to use best of breed software engineering approaches for education in quantum technology. Now, we're in a really unique position in that we have both a professional engineering team that builds products for a living, and we have a team of experts in quantum physics, including a number of current and ex-academics. And recently we brought on Chris Ferry, the author of Quantum Physics for Babies, a very famous children/adult author, enterprise author, who writes about quantum physics and all sorts of things in very accessible terms. He's become a quantum education advisor to us and is helping develop a lot of the content, because this Black Opal product is turning into an educational technology tool, right? With leveraging our special capabilities. You go ahead, Cindy.
I love that. Is that going to be, who are you targeting with education? Are you targeting sort of, upper primary, tertiary, high school, adults, everybody?
So the starting point for that is young adult in, undergraduate or enterprise, people who maybe are consultants, right, working in a bank or something, and want to get their feet wet learning about quantum technology. It's good for us that we can obviously expand that by changing the content without changing the product structure to be more suited towards high school students or something like that, to other markets. But what we see is that there is a large cohort of people in the market who are, professional age, right? That they're, in their 20s or something, and are really interested in this field. Well, how do they get into it? The cheap way of discussing it is it's like Duolingo for quantum physics, right? Mm-hmm. Really high quality educational technology using all the best insights about retention-based learning and blah, blah, blah. But with the best content coming from people like us who are academics who have worked on teaching in this field. But then, sorry, I want to finish off that thing, because, the market is more than that. There's one more product which is coming in quantum computing, which is called Fire Opal. And this is for, again, the very diverse set of potential end users, people who want to use quantum computers in, say, their programming, but don't have any idea what's going on in the hardware. And if you think about regular computing, conventional computing, there are a lot more people now who know how to code in, say, Python or whatever, but have no idea what a PN junction is that makes a transistor work, right? So as the quantum computers get more and more powerful, they also get more and more abstracted. And so you can program them without really understanding what's going on at the bottom. Well, those people also want the benefits of what we provide. We, because of our product focus, wrap it up in a sense, making it accessible and automated in a way that they don't have to worry about all the nitty-gritty details down at the bottom. So we try to cover all these different classes of users.
So I feel like the analogy that I was like, auto ML, you're doing auto quantum.
Yeah, why not? Sure.
I love it. I love it. That's great. I've got to ask a question before I get back to the serious questions. What is the connection to opals and why have you gone for opal? And what are you going to do? How many opals are there? And are you going to run out of them before you run out of products? Because that's a very serious product design question and marketing question.
There's actually quite a lot of different variations, right? There are Honduran opals, there's Mexican fire opals, there's water opals, there's white opal. There's a lot of variety, but the reason is when I was a kid, I was absolutely obsessed with gems and minerals. I had a gem and mineral collection, and opals were by far my favorite. And then, the cheekier product strategy version is differentiation, right? So it's not just, something Q that or whatever, but also it gives us the ability to have something that's beautiful and accessible and familiar, right? Opals, people know opals. From a nationalistic perspective, you can say they're a unique Australian gem that are globally coveted, and so are we.
I love that. A unique, so that's going to tie nicely into a question that was here that I want to ask about being a unique Australian gem, which I will refer to you guys as that now all of the time.
Thank you.
Why did you start the company here in Australia? Why here?
Well, so I lived here before. I came to Australia in 2010 to join a really exceptional cohort of research colleagues. For strategic and serendipitous reasons, Australia became a center of scientific excellence in quantum physics, in quantum science. And I became a faculty member running an academic team there. I live here now. I've lived here for 11 years, and it was the right opportunity in 2017 to start something. And so it was natural that I would try to start it here to leverage all of that R&D investment that had gone on, training all these exceptional people who many of whom were struggling for positions, right? Academia is very difficult in terms of job prospects, and not everybody wants to forego their background and just become a conventional software developer or something if they want a tech job. So this was an opportunity to capture that part of the market. And we've actually done very well. We've gotten a lot of people back, including some ex-Googlers who were quantum physicists, turned back to quantum physicist.
Yeah, I love it. Well done on that. And I think it's a great conversation to have as we sort of tick off into, you are growing. You mentioned you went from 23 to 43, I think, this year, which is huge. So massive, massive growth, almost doubled in size. So, if you're getting quick on some hiring.
The year's not out. We have a couple
you've got a couple of weeks left to go, and this is the perfect opportunity. But we've got a lot of questions. I've got a lot of questions in my notes, and we've got some questions coming through about what are you looking for? What kind of people are you looking for in your team now? And what will you like to be looking for? I'd say in the next 12 to 18 months, what skill sets they need to have, from a technical perspective, but also what skill sets from a non-technical perspective. So non-engineering, non-software, what other things do you look for? Because I know, hiring it's not just a case of, oh, you've got a quantum degree or you're a software engineer, that's it. What do you look for, and what kind of people, in terms of the other intangible skills, or maybe the other skills that people bring to the table in your organization, what kind of DNA do you look for in a QControl person?
QController.
QController.
So we clearly are hiring quite a bit more on the technical side, right? So we are hiring quantum control engineers. We're hiring machine learning engineers. We are hiring experts in sensing and navigation to join our team. Now, I just want to touch on that for a second. Like, we're not like some fluffy organizations that say, oh, we do AI and ML. Yeah, sure you do. No, we actually develop new algorithms for machine learning applied to the manipulation of quantum mechanical systems, right? We write scientific papers about new algorithms. We demonstrate them on hardware. Like, this is a core part of what we do. So if you come from the background of, say, robotic control, where you focus on reinforcement learning or model-based optimization for controlling physical systems, right? Machine learning for physical systems is a giant thing for us. We have a very big program in it. We've done some exciting stuff with IBM hardware on that, and we're continuing to boost that effort. Again, people with robotic control backgrounds for manipulating fleets of autonomous vehicles. A lot of these skill sets actually translate over into what we're trying to do on the quantum side. There's stuff to learn, of course, but that's very much of interest. On the product team, we're hiring front-end engineers, people who build our web interface, back-end engineers. We're hiring probably another DevOps engineer or two in the next year, people who make the infrastructure functional for our product space. I think in the longer term, we'll have more business development and the like. Right now, that is not our top priority. We've just hired a head of sales and BD. It's our first person in that kind of role as we systematize our product and sales playbook. But obviously, longer term, that's going to be a key part of it. Now, as for people and their skill sets, well, there's the obvious technical answers to that, right? ML at the edge, all these things. The things that one way I can answer this is what makes me really annoyed when I have to deal with it with an employee, right? So somebody who can't write really annoys me. You need to be able to write. You need to be able to write in really high quality, cogent English on technical and non-technical topics. If you can't string together 2 or 3 sentences to say what you're doing, there's a real problem with your ability to contribute. Not everybody in our team is client facing per se, but everybody should be able to produce material that can be used in front of a client or can be used on our website or whatever. Similarly, oral communication skills, extremely important, right? The ability to communicate what you are doing in either your research or your product development to a team. Now we use frameworks that facilitate this, like Agile and Scrum. But a really good hire would be able to communicate even without those formal structures. And then I think the idea of somebody who embraces that this is an exciting opportunity, that it's not just transactional 9 to 5, right? But also it's not exploitative. It's very fair in our compensation. We're very generous in our compensation and fair in the way we treat each other. But we look for team members who see this as like shared opportunity. It's not your ability to climb over the back of your peer to get my attention, right? Or to deliver something and, feel like you're the shining superhero. That doesn't work for us, right? The things we do are too difficult and have too many contributions from many different players. We need shared success as a motivator. So when the company rises, when we have a really good year like we did this year, and everybody feels part of it and is rewarded in tangible ways, that is what people strive for, not the upwards politicking or upwards management. Like that stuff doesn't work.
Yeah, I love it. It's one of those things that I think is, it's really good to hear you say that, because so often I think we are so founder focused in this country and we hero the founders and we talk all about them, but you've just sort of said, it is a shared success and it's a team sport. Entrepreneurship is a team sport.
Look, I actually think that the focus on founders at the expense of others is seriously detrimental to the deep tech or the broader tech industry in Australia. We had so little focus on it, we've overcorrected. First of all, not everybody should be a founder just because you have an idea. You should maybe learn something that you actually can differentiate yourself. So maybe make sure you go to university or really have some skill set, and then pick up some skills in the marketplace, right? I am not a spring chicken, as you can see from this. I built a research career. I built a really serious knowledge base. Many of my colleagues at QControl did the same. And then we come together in order to contribute to this effort. Well, the same is true, outside of QControl. Work in a startup for a couple of years, learn what it's really like, and maybe then go become a founder. It's not, founder at all at the expense of everything else is not the right mentality in my view. I mean, if everybody's a founder, then we have no employees and nothing works.
Exactly. Yeah, no, it's a really good point. You touched on something there, which is another one of my questions around seniority. You mentioned there's quite a few people on your team that have done this elsewhere and they've come and joined the team. What's the ratio of the balance between I guess senior and skilled folks that have got that sort of maybe industry or more senior research experience versus straight out graduate level kind of employees, or, you know, new grads at whatever level, including TAFE, what's that ratio look like? And what are the, you know, I know you've got 15 open positions right now. So what are you looking for to bring in now? Or do you have a fixed view on that? Or is it, or do you, you know, are you sort of dependent on who kind of emerges?
Well, we try to be responsive to the market in a sense. The first thing to say is that that profile has changed dramatically since we first started. Right now, as we founded the company, we brought in very senior people who were very experienced in our core areas of expertise, our you know, our area of differentiation, and in the complementary areas that we needed to make the business function. Right. So I hired a CTO who came with, he's a full stack developer, computer science degree. I'm a mediocre programmer on my best day, right? So we needed someone who really understood web-based architecture, who understood, you know, how to do everything from back-end engineering on the cloud through to React and client-facing frameworks. And knew the startup space, right? Like knew what it was like to interact there. It was not my background. So we hired a number of very senior people first. We filled out the core bits of the team, and then as that set of core competencies has solidified, it's become easier for us to hire more junior people, right? And there we've hired a number of people who are way more junior than we started, people who are in some cases right out of undergrad, who are just hungry and are showing us that they're excited about what they're doing, and then they learn very rapidly. So, you know, a lot of people get, you know, this informal on-the-job training. A number of people who come with non-quantum backgrounds and are now conversant in quantum physics and quantum computing, based on osmosis, if you will, just by being around us. I think going forward, you know, we still have in that list of open positions a number of senior roles that are required, very experienced people in certain areas like atomic sensors or the like. But we also develop opportunities for more junior people to come and cut their teeth with us.
I love it. Where's the mix between academic background versus industry background? Like, is that even? Is it a bit of both? Are you heavy? Because I mean, you're very heavy on research that you do, and because you need to be able to be pushing forward and, you know, really kind of still in that discovery phase and creating new things. But what's that mix look like? And I'm going to assume that that's changed, or it may change, but I'd love to hear.
Well, we certainly on the product side, most people would have come from, you know, professional engineering roles in places like Google or wherever. Yeah. On the quantum side, we have a handful of people who've had jobs in industry, but most are coming out of academia, either completing their PhD or similar. They get to learn how you take knowledge and insight and turn it not into a PDF for publication, but rather into a product that people can use. And similarly, the product team gets to learn how you don't just deliver, you know, something you click on for fun, but rather something you click on, it actually performs some very useful calculation, like a detailed optimization on a quantum system. I think that there is no hard rule about backgrounds. The head of our US organization came to us from a very industry heavy role. He worked at, you know, NASA. He worked in defense contractors with no quantum, but very serious machine learning for physical systems experience. And he's become, you know, an expert in quantum control, right? So there are all sorts of pathways in, and it's really about your, you know, how much of an expert you are in your area, and then how much you're excited to learn.
Good follow-up question to that is around the culture between academia and industry. And there's a question here about, can you comment on the differences you've noticed, and what have you intentionally introduced at QControl versus your academic lab, if anything?
Yeah, I'm just looking at the question now. Well, there are sector-wide differences. Obviously, like the tech space is a different culture than academia. I think the biggest thing is that the motivators are quite different, right? In academia, you know, we give up money so we can be left alone, right? So we don't have a boss that's going to make our lives miserable. We want independence. We want the ability to think and attack really interesting, hard problems that are interesting to us, right? It's about personal curiosity right? In building a product-based business, that doesn't work, right? You have to solve problems that other people care about. Now, we try to find people where their personal excitement and interests align well with what a customer also wants, right? And because they're similar in many respects, we have researchers who are building tools for researchers. It's not the hardest translation, but people who really want to like go off and sit in the closet by themselves and do pen and paper calculations, that doesn't work in our company. It is much more team-based for what we do than even in my academic laboratory, my experimental laboratory. I think there's also a much greater focus on active management of process in the company. Like academics just despise any kind of productivity tools. Because like it's about the free form aspect of exploration. And again, when you're delivering products and you have timelines, it's all Jira and Slack. That can be jarring for some people, but I think it's important in the context, and I've had to learn to embrace it. I also think when you have a more diverse team with less academic people and more product engineers or designers, things that I didn't do very much in my academic team. Like I don't communicate, try to inspire why we're doing this. Like everybody's motivated internally. They're internally driven in academia because they're making huge sacrifices to pursue their careers. They're, PhD students make like 25K a year, right? It's horrible. When you're talking about someone who has maybe a more transactional relationship with the company, keeping them inspired and motivated is a different and more important task. And so there's a much larger burden on me to be more communicative about company strategy and successes and things. And I'll readily admit that's not my strong suit. I have to work very hard on those things, but that is one of the things that I've had to pick up.
Yeah, I think it's really interesting that you mentioned that. I have a lot of people that come and say, I want to found a business. I'm like, don't be a CEO unless you really want to deal with people, because that's 90% of your day is going to be people management.
Yep. It's absolutely true. I am fortunate to have a CTO who really enjoys that part of the job. And so he takes a lot of the personnel management and lets me do more strategic things. But I would say the most important thing on that front is hire people who are good at the things you're bad at.
I love it. That's actually the greatest strength of how you build a really good, strong team. Don't hire people like you, hire people that do all the things that you're really bad at. I'm going to dive into some of these questions. And so the flow might jump over the place,
sure.
But I think this is a really interesting one. So is there any similarity between people working in cold chemistry and trapped ion quantum computing systems? What's your opinion? And can you explain that to those of us who don't work in cold chemistry?
Yeah. So unfortunately, I regret that I don't understand exactly what the questioner is asking about cold chemistry. What I can say is trapped ion quantum computing. That's what my experimental team does. This is where we trap individual atoms in a special electromagnetic bottle. And then because atoms obey the rules of quantum physics, by manipulating those atoms with laser beams and microwaves, we can kind of peek inside the quantum physics that makes them work. And then we can, of course, encode information into that. And here's a cute example, right? Everybody, I'm sure, has seen the intro to my least favorite show on television, The Big Bang Theory, right? And there you have the cartoon picture of the atom. So you have the nucleus, and then you have the electron that whizzes around, right? Everybody knows that picture, that cartoon, right? Well, that's a cartoon of quantum mechanics. It's a cartoon that's saying that the electron, the outer part of the atom, can be here, or it can be here, but it can't be anywhere at once, right? That's quantum mechanic. The allowed states are quantized, they're discrete. Well, that idea of the electron's going this way or it's going this way, they're different. And we can make the electron go into one or the other using laser beams. Well, there's your one or your zero, right? It's going this way, it's going this way. Of course, this is a really simplified cartoon representation, but that's how we can use trapped ions in order to perform quantum computations. And chemistry is one area where we solve problems using these trapped ion systems. So I hope that was close enough.
I'm hoping it was close enough for the person that answered the question, but it was a fascinating conversation. And I do like the pop culture reference because I think it's important that we do, pull those out for people. And I also have, I've got to say, a slight wish that you were my physics teacher back in school, because I might have had a chance of understanding some of the things a little bit more deeply than what I do.
That's nice of you. Thank you.
Although I might have made you cry. So just saying.
Oh, that's harsh.
What's the best way to meet other people who work in quantum computing? I have absolutely no idea. Do you host parties?
Well, not in the COVID era. What's the best way? I mean, there are growing communities of interest. I would say one way that you should keep an eye on, please, is that this Black Opal educational tool has a community function to it. It is not just a mobile app where you go and you do your thing. It's community based for Q&A and moderated discussion. It's designed to help bring together people who are starting their quantum journey, people who are learning, figuring out what this is all about, and then hopefully using that knowledge to make an entry into the community. In Sydney, just yesterday, and I hope my friends are listening, we launched the Sydney Quantum Academy, which is a joint venture between 4 major research universities in Sydney, focused on really the PhD level. So the educational challenges associated with making Sydney a global hub of this kind of R&D, primarily of the science. But that is going to have, is likely to have, I won't speak for them, is likely to have outreach and engagement with industry, with enterprise, with the broader public community, who are interested in this field. So if you're Sydney based, then that's an opportunity as well. But Black Opal 2.0, which is coming in 2021, is the biggest thing.
And I'll just put it out there that the Quantum Academy is right next door. So you're Sydney based, we're here. I'm pretty sure we could actually do some sort of something together to actually bring, some of those people, some of you physically together next year and have a conversation, and certainly online, because I do think connecting the dots and, making Australia a real hub for this is a really, really great opportunity. Another question that's really interesting to me, as an Australian company with a primary market overseas, particularly in a year where you can't travel, how are you identifying and engaging new customers for your solutions in new overseas markets?
It is an interesting question. So the first thing for context is that in a normal year, I'm on a plane 2 weeks out of the month, right? So I live roughly half time in Sydney. And then the rest of it is, giving invited talks and meeting customers and the like. So, when the vaccine is here and things are safer internationally, it is going to go back to that. There's no question. We engage with our customers in kind of 2 general ways. One is leveraging our network, right? I am a professional who has been active in quantum computing since before the field was a field. And so that has afforded me a professional network that I leverage. And the same is true of many of the senior members of my team, right? We're people who've been active in the field for a long time, and we leverage that network as a trusted provider, as a trusted known entity, in order to identify prospects, whether those prospects are new industries emerging or potential academic users of our work. But we also, we have a senior manager for marketing, and that manager for marketing does, proper digital marketing, where we have, sometimes Google AdWords campaigns. We like LinkedIn as a targeted vehicle a lot because it lets you get more professional users for the kinds of products that we're pushing harder right now. But we have, the same kinds of capture campaigns and recapture marketing that you would employ in any product-focused company. And we just did a test balloon where we do a webinar series, and the webinar series is a great way for people to learn about our products, with real interactive. It's like this. It's on Zoom, and we've relied on our existing organic database until now, and for the first time, we've done a proper paid marketing campaign to capture new prospects. And a third of our registrants are people we've never talked to before, right? But they are professionals from the right institutions with the right job titles. So it's an investment in proper digital marketing.
I love it. It's really good to hear that. And actually, it's really interesting to hear. I don't know that LinkedIn would necessarily think of themselves as a platform for quantum computing and business engagement. But we talk to a lot of our deep tech companies about it too. When they come in as emerging founders, they're like, why would I put my business on LinkedIn? Why would I think about this? And it's like, well, actually, you do. The way that you do it might be a little bit different to, other solutions out there. But actually engaging that audience and connecting with them and connecting with the right people in the right company is super, super important.
Yeah, look, I mean, you bring up a fair point, which is, there's not a lot of PhD students in, say, quantum physics who are on LinkedIn. The first thing I'll say is if you want to be in the industry, as opposed to just being an academic, then you should be on LinkedIn, right? For good or for ill, it is the de facto standard. Like, as much as I despise Slack, it is the de facto standard, right? So we need to accept that. But LinkedIn also, in terms of its marketing automation, is quite good for targeting not just individuals, but people in particular roles or in different known organizations.
I'm going to ask one more question from the Q&A, which just popped up from Georgia, saying, thanks for the avenues outlined so far. What skills do you think physics undergraduates interested in quantum computing need to develop more of?
Well, if you're a physics student, you should study quantum physics. I'm gonna climb on the back of someone else right now. Australia has this cultural love for astro. And, a lot of people like to go into astronomy. Well, if you want to be an astronomer, go and do astronomy. If you want to be a professional in the quantum computing industry, then at the undergraduate level, you need to learn via your electives quantum physics, right? So that's not just the core quantum physics, it's also the atomic physics. And there's these emerging areas of what they call quantum nanoscience, like the circuit level stuff, and also quantum information. All of these things are available, right? And you just need to do it. The corollary to that is the set of skills that go beyond the core fundamentals over towards practical implementations, and their programming is scientific programming in, say, Python or at least MATLAB is one of the most important skill sets. If you're more proficient coder than that, if you're like doing backend engineering stuff, like that's also great, but that's not really that important. Like, as long as you can write scientific scripting programming, we can teach you the object-oriented language that's required in order to build products and build really high quality code. But you need to be familiar with taking a physical system and turning it into a model in software. That's a really important bit, whether you're an experimentalist or a theorist.
Awesome. So I get to, as moderator, ask the last couple of questions, which I want to be future focused for a moment. So we know you've got 15 positions out there and you're hiring and you're growing. What does the next 1 year, what's the next 12 months, what's the next 3 years, and what's the next 5 years look like? Or what do you think they look like for QControl?
I mean, obviously there's continued growth. We have several new products that we're looking to launch next year. So Black Opal 2.0 is going to be in, alpha release in first quarter, probably, or second quarter of 2021. And then mid-year, we're looking to have the full public release. Fire Opal, the product for end users and developers who want to effectively compile their circuits using our capabilities. That's later in the year. A lot of growth in our atomic sensing and atomic devices team, building out our quantum sensing capabilities. Continued global growth. We are currently establishing a legal entity in the European Union. So we have an office in Berlin. And we're going to look to expand our footprint in that market and a lot of business development, right? We've had a great opportunity to build. And as things emerge from the post-COVID era, that's the time to engage and sell, right? And make sure that we're everywhere. We're contributing everywhere we possibly can.
How big do you want to be?
Infinite. I think, our ambition is to be the trusted provider of quantum control across all applications, and the team will be as big as is required in order to deliver on that vision. I don't start out like, I'm not motivated by like, I want to be as rich as Zuckerberg or something, right? That I also don't want to be quite as horrible a human being, but I think, there's clearly a scale at which things start to really change in terms of your impact. And, I can easily see that in the next several years, we get into the hundreds of employees. And beyond that, whether it's, 5,000 or 100,000, I honestly don't know, right? It's what is the scale required to really deliver on our vision of being everywhere. And if we can do it in a lean way, we'll clearly do that, right? But, we intend to grow.
I love it. It's really phenomenal to hear you talk now, and if I reflect back just, a few years and the conversation then, to actually see that growth. I think so often people will probably be, there's probably people watching this call or who watch the video afterwards, who it's the first time they've heard from you. It's the first time they've heard about QControl, and they're going to be like, oh my gosh, this is happening and it started in Australia. Amazing. But, we know that journey has been going for quite some time. And it really even started before the company formation. It starts on your journey and your vision and the creation of that, and then stepping into it and the struggle along the way. And I think it's just phenomenal to see a little bit of where you've come from. And I've been privy to see some of that, to see where you are now, but actually to hear you talk about where you want to go and what that future looks like. I think it's such an exciting time for the company, for you, for us in Australia, globally. The potential is huge. It's really great that we've got an opportunity to direct people to our forms and to our website to sign up, to find out more about QControl, and also to, apply for those jobs that you've got opening, so that we do help you double in size before the end of the year, if you can get that recruiting time. But it's just phenomenal. And I just want to give a moment to congratulate you on where you're at now. I know it's not the end, and I feel like it's probably only just the beginning in so many ways, but I just think it's phenomenal. And I know the hard work, I know the blood, sweat and tears that have gone into getting to this point, and that there's lots more to come. But I think it's amazing, and it's really exciting to have you here in Australia doing this. And so from everybody watching and from an entire community, I just want to say thank you. Thank you for giving up your time today, which is incredibly precious. And you could be spending it in working with your customers and growing, but you've spent it with us, and you've spent it with educating people and sharing that journey and inviting people to participate in and support you. And I just want to acknowledge that and say thank you. Thank you for that.
That's extremely kind of you, Sally Ann. I mean, I appreciate that both you personally and Cicada Innovations have been great advocates of ours. We're very excited to be doing this kind of work here. I wanted to make two requests of the audience, please.
Oh, yes, please.
One is, if you're interested in our positions, please go to careers.qcontrol.com. Have a look at what's there. If you don't see exactly what you do, you're welcome to get in touch. It's not a guarantee that we're going to make another hire, but we are opportunistic and sensible about that. And then the other thing is, if you're excited about this kind of work, whether you want to work at QControl or not, if you're excited about building completely new deep tech industries in Australia, please contact your politicians and tell them to make sure that they value this. Now, there are lots of ways they can value this. I'm not currently asking for money. I'm asking that they set policies around foreign investment that support us, because right now the Australian Commonwealth government is trying to restrict our ability to raise venture capital from, say, Silicon Valley. Now, we understand that there are security concerns that are real and legitimate, but cutting off VC-backed technology and investment from Silicon Valley is not the way to achieve it. So if you want to see us stay here, and not just us, but anyone like us, please do contact your representatives and your MPs and tell them that foreign investment review modifications need to comport with the venture capital business model. They need to support this sector.
I love it. It's a good PSA. And if anybody needs some facts and figures about why deep tech matters and we care about it, you can hop onto our website and look under About. And Australia's Deep Tech Opportunity is a report that we commissioned and released earlier this year that talks to some of that and has got some numbers about why we need to do this and why we need more global R&D companies born and staying in Australia. So incredibly important PSA. Please get it out there. If you do, tag both of us on Twitter and tag both of us on LinkedIn, and we'll probably share that message further and wider. And one more PSA to do too for Shadow Control. If you want to stay in touch with them, you can obviously do that on their website, but follow their LinkedIn page. So they are pretty prolific. And you can also follow Michael and team on Twitter as well. And he's definitely prolific on Twitter and sometimes highly entertaining. So you should definitely do that and stay engaged, because it is a real community and we value that community. So with that, we are at the end of our time together. Thank you everybody for your participation today. Thanks everybody. Have a great day.